Alright, so what we're going to work on is the factorized remainder theorem. The remainder theorem is what's if you divide any polynomial by its factors, then whatever remainder, whatever number that cannot be dividable anymore, that's the remainder. Each polynomial, when you factorize it, will consist in multiple factors. Each factor is equal to 0 because if you multiply all the factors to, each factor is equal to 0 because each factor satisfies the equations. When you factorize polynomials, you remember that we always need to make it equal to 0 before we start factorizing. So once we factorize, that's when all those factors, if you substitute them, solutions must give you a 0. And that's what we're going to use our starting point from. Okay, so you just remember each factor must equal to 0, and before in the level 11, maybe 11 or even year 10, when you factorize and you want to find solutions after factorization, remember when you say because all the equations equal to 0, that's mean all the factors multiplied together give you 0, and the only way you get a 0 as an answer, that's mean all the factors must equal to 0. So 0 times anything is 0. Alright, so that's the idea about finding solutions, and that's what we're going to use today. Now, how are we going to use the factors to find the remainder of an equation? Remainder means things cannot be dividable. So this is, if you divide any equations, you will have a multiple of factors plus a remainder. That's the remainder that we want to interested about this time. So that's the polynomial. This is what you're dividing it by. Those are the quotients, and that's the remainder. Okay, so for example, if you have any polynomial you divided by one of the factors, you will get an equation plus a remainder. So if you have, so that's the factor here, x minus a is a factor. So we said the factors will equal to 0, so x minus a equals 0, that's when x equal to a. Now if you substitute that a back into the polynomial, you will know the value of the r, or the remainder. And that's what the remainder theorem is. Now, for example, what's the remainder when you've got an equation 2x to the power of 3 plus 5x minus 6 divisible by x minus 1? Now, because we already know it's going to be divisible by x minus 1, so that's mean x equal 1 is one of the solutions. So x equal, substitute the 1 back into the equation, you will end up with 1, and that's the remainder. To double check, you can do a long division of 2x to the power of 3 plus 5 minus 6, and you will end up with a remainder of 1. Now the next questions, if you have divisible by x plus 2, now x equal to negative 2 substituted back into the equation, you get negative 32. And you can always check those answers if you do the long division, the polynomial long division. Now find the value of a. If x to the power of 3 minus 3ax squared, all this polynomial has a remainder of 8. So this time they gave you the remainder, they gave you the factor, which is x minus 4. Now you want to find the value of a that is in the equation. So you will, first step, you will make the factor equal to 0. So x minus 4 is equal to 0. That's when x equal to 4. So you will substitute, if that means using the remainder theorem, if you take the 4, substitute it back into the equation, you should end up with a value of 8. So now if we substitute the 4 back into the equation, we end up equal 8, must equal 8 because that's the remainder. So you can see now you've got an equation with a only unknown. Rearrange, simplify, and solve, and you get the a is equal 1 over 3. This is slightly harder. You've got an equation, a polynomial here. You've got a and b as unknowns. This polynomial has a remainder of 4 when you divide it by x minus 3. You've got another polynomial has also a and b as unknown. But this polynomial has a remainder of -8 when divided by x minus 1. Your job, obviously, to find a and b. Now, we're using the remainder theorem in here. So let's take the first equation. So you've got, this is the factor x minus 3. So you make x minus 3 equal to 0. That means x equal to 3. So if you substitute 3 back into this equation, you should get an answer of the remainder, which is 4. And that's what we're going to do. So rearrange, simplify, and you get the first equation. The first equation is 9a plus 2b equal -14. Because we've got two unknowns, to solve them simultaneously, you need to have two equations. So now let's come to the second equation, and we will do exactly the same. Second polynomial, substitute x equal to -1 and give me the answer of -8. Substitute, rearrange, and you get those two equations. Now you can use your graphic calculators to solve those two simultaneous equations, because the point here is not testing you how to solve simultaneous equations. So you've done enough thinking for this question. So you go to the graphic calculators, just a reminder how to do that. You go to menu, equations, choose simultaneous, I think is the first option, and then two unknowns, and then you plug in the numbers. So you plug in 9 to -14, you plug in 1, -3, -8, press execute, and give you the answer of the 2a and b. This is if you would like to solve it algebraically. So I've got here, I've used elimination. So to do the eliminations, I need to have both a's, whatever you want to whichever variable you want to eliminate. So I'm eliminating the a, that's why I'm multiplying the second equation by 9, and I get those two. Now the two signs are different, so if I add them, it's giving me this, so that means b is 2. Now taking the 2, substitute back into any of those two equations. I'll substitute it in the second one, it's easier, and then you get the answer of -2. So that's the solutions for a and b. Again, I'm repeating, if you don't have to do this. If you don't want to, you can use the graphic calculator. This much thinking is good for this question, as long as you know how to substitute, rearrange, and how to use the remainder theorem properly. Thank you.